Okay, so we are at 10, 18, 19. Wow, that's kind of weird. Okay, logarithms. So, logarithms are exponents. You're going to hear me say that several times. Logarithms are exponents. Well, what does that mean? Well, let's check it out. So if we take something that's in an exponential form, right? And we're going to transpose it from exponential form into log form, then logs have bases, right? Whether it's base 10, base 2, whatever. Every log has a base. So whatever number this is the base. So you get the log of that base. And then you take and put this number here of the answer equals the exponent. So logarithms really are exponents, aren't they? And they help us solve for exponents. It's really slick. Because some problems we saw earlier, like 10 to the x equals 321, you couldn't do that. You could guess and check and guess and check, but the logarithm calculator, slick. Now you did ask a good question, Austin. You're like, what about another base? We're going to get there, okay? So first of all, let's just practice like we did, changing it from exponential form into log form, okay? So we're going to go straight to log base 10 of 10,000 equals 4. You guys see that? So it just shifts it from there to there. So we can go log base 10 of 10,000 equals 4, okay? Log of the base, okay? And you can go both directions, okay? So I just did what we did. Log, that's my base number, goes down there, of my answer, and it always equals the exponent, okay? And of course you can go and transpose it to the other form. Let's put it back the way it was, okay? So to put it back the other way, we can go, here's my base number, right? That's my base, so 10, and that's my exponent. So 10 to the 4 equals my answer, which is 10,000. Thumbs up? It's really not that bad. So on example 2, we'll do the same thing. We'll change it to log. That's my base number. So we'll go, okay, log. That's my base number, right, of base 2 of my answer of my 8 equals my exponent, which is my 3, right? Not too bad. We practice this a little bit in our journal. And again, we can transpose this back to log form. So from log form, we can put it back into exponential form. So that's my base, right? That's my base. So I'm going to go 2 to the 3rd power equals 8. So all I'm doing is transposing. Today we're not going to do a lot of solving with exponents. We're just going to get used to moving them, okay? Because if today is just getting used to moving them, then we start to solve them, it's going to be easier, right? Okay, so then E. Wow, E. Now here's a special log, okay? So E comes from log base E, okay? So if I go log base E of 7.389 equals 2, base E, log base E, I look at my calculator, okay, is a special log. It really is. Right here in my calculator, if you guys can see this, but you see the base E right here? So if I look above my calculator, log base 10. So the invisible log, or the invisible base was 10, right? Invisible base is 10. Well, with base E, it's called a natural log. And the reason we call it a natural log, we learned yesterday that the number E we see in nature. Anything that grows continuously is something we find in nature, right? So the log, we're going to totally rewrite this. Please rewrite this as ln of 7.389 equals 2. So when you see ln, it means natural log. I know log that's natural, but it is. So when you see log base E, we're going to write natural log. And it's invisible base is E. Okay, I'll say this again. So when you see log base E, it means natural log. Its invisible base is base E. Okay, so, or when I see ln, its invisible base is base E. Okay, so if that's the case, if I have ln of 7.389 equals 2, my invisible base is base E, okay? My invisible base is base E. And I go E to the 2 should equal about 7.389. So, if I had an E button to solve for, I would use this. Okay, guys, ready for me to turn the page? All right. Now, change to exponential form. So now we can do it just the opposite. We can go, here's my base number, right? There's my base number. So we can go 3 to the 4th power equals 81. That's my base number. 3 to the 4th power equals 81. And that makes sense, because 3 times 3 is 9, times 3 is 20, times 3 is 81. So it really is 3 to the 4th is 81, okay? 5. Okay, now, solve for x. Now there's two ways to solve for x. One, you can use your calculator. You can. Because what's my invisible base? 10. So I can go, okay, well, gosh, if it's invisible base, a calculator does, yeah, you've already got it. Exactly. So Isaac and I got the darn answer before we even picked up the calculator. Anybody else got the answer to this one without a calculator? Yeah. What do you, 2? Do you guys agree with 2?
Yeah.
So, I mean, but the calculator should get 2 also, and I'm going to show how you got 2, okay? Nice job. So if I go and use it's invisible base, so if it's invisible base, I've got a button in my calculator, log 100, and sure enough, it equals 2. Nice job, Isaac. I totally agree it is 2, right? 2, oh, there's my 2. It's just kind of like a little bit of a glare. So, invisible base is 10, right? So I'm going to go 10 to the x equals 100, and of course 10 squared. It's got to be 2.
You screwed it up.
Yeah, I sure will. Okay, thanks. So it's got to be 2, because 10 squared is 100. So x has to be 2, but we were able to get it on the calculator, right? Okay, example 6. Almost done. Example 6. I got this ln. What's my invisible base? E. So if I rewrite this as log base E of x equals 2, right? So I can't do that, because if I try and take ln of x, it doesn't work, okay? But I can change this. That's my base, E, to the 2nd period equals x. And then we can use our calculator using our E button. Okay, I can take my E button. E to the 2nd power is about 7.38, blah, blah, blah. Kind of glarish there. Yeah, that's better. So I get x is equal to about a 7.389 approximately. Okay, so that's not too bad, is it? You guys agree? Okay, that's about all I have. Okay.